Okay, in this video we're going to have a look at the organization of the periodic table and link that to electron configuration or electron arrangement. Okay, so I'm going to start off with the periodic table first of all. And the first thing to point out to you is you can see these small numbers going across the periodic table here. So we've got here number 1. This is a group number. So this means all the elements in this column belong to group number 1. And then we have group 2. And we jump across to group 3 and so on, all the way here to the noble gases, which is group 0, the last one on the periodic table. Notice we skipped across these in the middle. These are called the transition metals, and we'll come to do more on that later in the course. It's also worth noting that as you go across the periodic table, these are called periods. So the first period, always make sure you include this one, is hydrogen and helium, 2 elements. And then the second period goes from lithium all the way across to neon, and then the third period is sodium all the way across to argon. Okay, so periods go across, groups are the vertical columns within the periodic table. So how does this, or one of the things I was going to mention to you is these red steps here, all the elements on the left hand side are the metal elements, and you see there's a lot more of those, and on the right hand side are our non-metal elements. This is a great way to understand metals and non-metals in that division. So how do these arrangements work? Well, you'll probably see me draw this diagram here a lot on the board. Well, if I can bring it down for you. Probably see me draw this diagram a lot on the board. This is my little sketch of the periodic table. There's my divide, metals and non-metals. Our groups, remember the vertical columns, 1 through to 0. And then the periods work our way across the periodic table. And the way this links to electron arrangement is as follows. You should know that electron arrangement, the electrons live in energy levels, and each energy level can only hold a certain number of electrons. So the first one can hold 2, the second one can hold 8, and the third one can also hold 8. Bring that back to this. There's a pattern. The first period has 2 elements. The second period has 1, 2, 3, 4, 5, 6, 7, 8, and then the third period also has 8 elements. So this pattern of 2, 8, 8 reflects the arrangement of the periodic table, 2 elements, 8 elements, 8 elements in each of those periods. So our first rule linking periodic table to electron arrangement is that the period number, the row that the element is in, is equal to the number of energy levels the element contains. So if you're in the third period, you have 3 energy levels. The second rule is the group number. The group number on the periodic table is the number of electrons in the outer energy level. So if you live in group 3, you have 3 electrons in your outer energy level. So the 2 rules that link the periodic table to electron arrangement are that the period number is the number of energy levels, and the group number tells me the number of electrons in the outer energy level of an element. Let me show you how this works. I'm just going to pick here on silicon. Okay. Silicon, I can see, let me just write silicon down so we know we're dealing with silicon. I can see from here that silicon is in the third period. Because it's in the third period, it means it needs to have 1, 2, 3 energy levels. I can see that silicon is in group 4. So the last energy level must have 4 electrons. These first ones are full, so it's going to be 2 and 8. So the full electron configuration is 284, which adds up to 14 electrons. And if I look here, I can see that that is correct, that silicon has 14, the atomic number 14, so it has 14 electrons. Let's pick another one, just for example. Let's pick on boron. So I can see that boron here is in the second period. So that means it has 2 energy levels. I can see it's in group 3, so the outer number of electrons, the outer energy level is 3. The first one must be full, so it's 2, 3, which is 5 in total, and the atomic number is 5. So that's how we link electron configuration to the arrangement of the periodic table and the organization of elements. Okay, good luck.